Good afternoon, friends. Due to curvature, our OH design is need attention. Another term is super elevation. That means due to centrifugal force, the train or a locomotive on cart track has a tendency to go out from the track, and to resist it, the outer track is raised, and the amount of this raising from inner track is called super elevation. Due to super elevation, the pantograph axis will also shift. So our pantograph running zone is affected by this super elevation. So we'll discuss this super elevation. Dear friends, today I failed to upload the video till now as because my PowerPoint is not working. My laptop I purchased in the year 2014. It is HP Pavilion. So after so many years, it is giving trouble. Now it has opened and I shall try to upload a video. Super elevation. Already you know that in curvature, due to centrifugal force, if train is in motion with adequate speed, then the tendency is to go out of the track, and to give resistance against it, the outer track is elevated, and this elevation is called super elevation. Means the rise from the plane of the inner rail to the plane of the outer rail. If it is D, then D is called super elevation. Due to this, the locopantograph also shifted. How much shifted? It has been shown in the calculation. It will, if the elevation is D, then D is equal to dH by G. What is this displacement D? It is in capital D is equal to super elevation small d into height of contact wire divided by track gauge. So this is the formula, and the pento will shift accordingly. So you can provide mast in inner side or outer side, and pento will shift towards inner side. So extra stagger of plus 100, that means our normal stagger is 200 plus 100, 300 millimeter shifting we give here to keep the pento under the contact wire, so that the pento will not break. So this is the pantograph displacement. I have shown it here, and read it and try to understand it. Okay, thank you. Here the two pictures is showing our OHE mast can be provided outside curve side, that means after the outer rail, and also inside curve, that means after inner tail. In outer side, the tendency of contact wire is going away from the mast as wire tries to become straight in the curvature. So it will go, it has the tendency to go away from the mast. But in inside curve, its tendency is to come to the mast. So according to it, we are adjusting our cantilever to keep the contact wire in the Pinto working zone. In the curvature, previously we are providing 300 millimeter of stagger, where in normal 200. It may be away from mast, it may be towards the mast. Away from mast is called plus stagger, and towards the mast it is called minus stagger. So this is the mast in the curvature. We have seen how to find out the span length and everything. A practical example will be given how to find out the span later. Let's see. Good night. Friends, suppose the curve is 2 degree. If you keep the versine is equal to 300 millimeter, means 0.3 meter, then from the formula r is equal to 1746 by theta. Here theta is equal to 2 degree, so r is equal to 873 meter. Again, we know V versine is equal to span square divided by 8r, or 0.3 is the versine span. We have to find out 8 into r is equal to 873. So L is coming around 45.77. It is non-standard. We know that the span is from 27 to 72 with the multiple of 4.5 meter. So 45 is a standard span. Next span is 49.5. So better to take 49.5. No. Better to take 45. If you less the span, then adjustment will be better. Take the span 45 meter. So the span will be adjusted. Say yes. Curvature which will be adjusted better. Thank you. Good night.